Hello, David. How are you?
Hello. Hi, how are you? I'm great.
Where are you right now?
I'm in Israel. I'm in a city called Netanya. It's in kind of
Okay,
in the middle of Israel, near the
okay,
ocean.
nice.
Yeah.
It's really cool. And thank you so much for being here with us today. We are really, really happy, the Jenny DAO community, to have the chance to interview, to be able to interview you because it's really impressive your work, and we have a lot of questions about it. Um, so we're gonna go through this process a bit later. My first question gonna be really simple, but who are you and how did you finally start photography?
So I'm David, and I'm 39 years old. I've started photography in the past 5 years, I would say. Well, I always liked photography, but as for deep space photography and all those amazing objects. This is something that I was enthusiastic ever since I can remember myself. When I was a young boy, I built a telescope with the help of my grandfather at
Wow.
the age of I think 13. So ever since then, I was really enthusiastic about science and space and all those amazing objects out there, and just figuring out our place in the universe, and just even trying to grasp the size of all those things, how small we are compared to the universe. Um, so it's something that I was interested ever since I can remember myself. So yeah, but for the more professional space photography, as I said, it's about 5 years, 4.5, 5 years.
Also, it's nice that finally you're able to really share your passion to everybody. If it's something that you have inside you since you are kids, it's really cool. I think you must be really proud of it to be able to share it and to grow around it. So it's nice.
Well, yeah, I am proud of it, but I'm kind of a very I have high expectations of myself, so I always try to kind of improve. I never feel like I'm satisfied with the result, even though a lot of people really enjoy those pictures that I take.
Yeah, because um, you are so sharing. When did you create your first actually NFTs collection about astronomy? Like, did you first of all you start photographing 5 years ago for your own pleasure? That's correct. And but did you add already at the beginning the material, or because it seems that it's something really different from a simple camera? And this is a question that a lot of people ask: how are you able to have such detailed picture of something that is so far away, and that is actually, if you don't say that this is, for example, the sun, it's impossible to imagine it. If
Yeah.
so, what kind of material do you use?
Yeah. So, well, to go back to the first thing you asked me about, when did I start with the NFTs? So yeah, as you said, I started photography mostly for myself. The first time I went to the desert, to a very dark location, and aimed the telescope there, and just saw like the live view on my computer screen, about 5-10 seconds exposures of the Orion Nebula. I was blown away. I didn't even know that it was possible to see it like this in a live view. Um, so the first images that I took were in terms of quality were very bad, but they did got me hooked on the subject, and yeah. So the first one was for myself, but then later on I got a lot of attention from a lot of people really liking my photographs, and starting following me on social media and all that. And that's when I decided, I want to take this to the next level, and try to really get like the best possible results and the highest resolution pictures of objects that I can, because it's kind of it's a field in that's got a lot of attention nowadays, the deep space photography. So a lot of new photographers try to capture those objects, but I wanted like to be unique in a way that I would get like the smallest objects and the dimmest and farthest objects, and to try to get the highest resolution images of them. So that keeps me, that drives me to constantly try to improve my methods and my equipment and my processing abilities and all that. And for the next question was, how am I able to even do those? Yeah. So it takes a lot of there are a lot of different stages that you go through when you capture those objects, and it also depends on the type of target. There are different types of targets. For example, when you do solar imaging, you have a lot of light because of course, sun is the brightest object in nature, and so you want very short exposures to try to get a lot of good data, because the atmosphere is just so turbulent and it's always moving. So you want to capture as many images, as many still images of the way the atmosphere is currently is, and without the disturbances. Sorry. And as for galaxies and nebulas, those are very far away objects, so they're very dim. And what you want to do is capture long exposures. But that cause a lot of other problems and other issues that you have to compensate. For example, of course, the Earth is rotating on its axis, and so the sky is constantly moving. So you have to, if you ever taken a long exposure image, you know that that movements is like the worst thing that can happen to a picture, because it creates trailing and smearing. So we want to compensate the rotation of the Earth with a very special tracking mount, and also the tracking mount itself has its own problems and all microscopic imperfections. So you have to compensate for that with software and keep track and always correct the position of the mount to be able to do those long 10 minutes exposures sometimes. So yeah.
Yeah, to be honest, I tried last summer to do some photography of the stars, and I thought it was easy, because I had a camera, and I check on Google, on YouTube, how to, like capture stars. It seems so easy. No, 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 no. Yeah. So everything what you say, like this whole process, it's true, because the tear is rotating and you have this rotating on the other side, and so everything needs to be really exactly set up, and then sometimes you have to wait really long time. So actually, and of course the pictures that I took was black. It was nothing. So what I want to say is, it's true that we cannot really understand how much precision, work, and commitment you need to realize this kind of incredible picture. And my question was, how much time, most of the time, how much time do you need to have this one good shot?
Well, again, it depends on a lot of things. Let's start with just the conditions of the atmosphere. So
Yes.
firstly, you want to wait for a clear night without any clouds. And no, even thin clouds can ruin the image. So you want like a completely clear night, and you want to go to a very dark location where the city lights don't cause the atmosphere to glow. And also you want to the atmosphere itself, even when there aren't any clouds, there are different turbulences and airflows that can affect the picture, especially when you're trying to capture a more zoomed in kind of picture. Okay, so like to capture those smaller objects, because as higher zoom as you go, then each small movement causes a lot of more problems. When you take a very wide field view, then the stars are almost not moving, but when you zoom in, you can see that they're moving a lot. So those are the things you want to take into consideration even before you even think about equipment and all those things. You just want to have this location that is drivable, that is in a driving distance, and the right conditions of the atmosphere, and of course you don't want the moon. Also, you want to go in the time of the month where it's a new moon, so because the moon, of course, also creates a lot of light and ruins the images. So that's the first thing. But then you want, as I said, if those are dim objects, you want a very precise tracking. So you want a good mount that can track the sky very accurately, and
Yeah.
you also need to kind of yeah. I think we got disconnected for a second.
Yes. Sorry. All good. All good. Sorry.
Okay, good. So other than, as I said, other than just tracking the sky, the mount itself has its own imperfections and periodic errors that you need to compensate and correct. And also like the positioning of the mount, where when you position the mount, you do this by hand and you aim it at the North Star, because the mount needs to track the sky with the rotation of the Earth around the North Star, celestial pole. So so even this can it's not perfect because we aren't perfect. So you need to constantly correct the position of each frame that you take, and during even the frames that you take. For example, if you take one frame of 10-minute exposure, during this 10 minutes you need to constantly correct the position. So you have a secondary camera and a secondary telescope on top of the main telescope, that all it does is just looks at one star and try to make the star stay at the same spot, just constantly sending periodic corrections to the mount from the computer to correct the position. So this is just about the data gathering. Of course, there's the second step where you need to process all this data, which is also very tricky. You want to take all those frames that you capture of this object and stack them together to create just one frame, one image, and then of course process it. And it depends, of course, on if you use different filters. For example, this image that we see behind us was taken with 3 narrowband filters, which are
Actually,
special filters. Sorry.
Actually, it's the ones that DavidDayag here. We would like some explanation about it, some insights. Can I
Okay,
share?
let's start now.
This we will see it in full. Okay, I just share my screen like this. You can explain us because it's really impressive. Cool. So please continue. Excuse me. I up.
So you want me to talk about the picture? Yeah, cool.
Yeah, because this is the pictures that is the background and the ones that work here, and the Eagle Nebula. Wow. So how did you manage, for example, to have all of the stars? So it's as you said, it's a superposition of different not different photograph, but different correction at some point to make it the most realistic. I mean, not realistic, but the most accurate possible, without the rotation of all the elements.
Yeah, exactly. So first of all, this is an image, as I said, of the Eagle Nebula, which also hosts the pillars of creation at the center of it. So this is a kind of a wide field view of the entire nebula, the entire Eagle Nebula, which kind of the shape kind of reminds an eagle if you look through a telescope. Less when you look at it like this, but when people named this nebula, they didn't those methods didn't exist yet, so it looks like an eagle. So it was captured with 3 different filters. So that means that you put one filter, then you capture several frames of that filter. Mostly I throw away about 90% of the data because most of it is very bad, and I want to keep just the sharpest frames. And then I would take those frames of this specific filter and stack them together to create just one image of that filter, and this will be assigned to a specific channel. Like you have RGB channels, right? Red, green, and blue. So you take one filter and assign it to one channel, and then you take another filter and assign it to a different channel. So it was taken with 3 filters, as I said. It's called narrowband filters because they're filtering all the light waves, all the spectrum, except for a specific narrow band of the spectrum. So one of them was hydrogen alpha, which is the spectrum of hydrogen emission, and one of them was oxygen, and the other was sulfur. The hydrogen is assigned to the green channel, the oxygen to the blue channel, and the sulfur to the red channel. And this creates this very colorful and very detailed image.
Exactly, really colorful and colors that we are not used to see, if I can say it on this way. You have so much different shade, and it's look like a painting on a way. So how much time, for example, if we just talking about this picture, for example, how much time of work? And when I said work, I'm talking about the whole process, from the preparation, as you say, the really early stage idea of where you're gonna go, at what time, the shoot himself, and then the post-production. How much time? Just to have an idea.
So yeah, first of all, this is a very a very famous sorry nebula because it hosts, as I said, the Pillars of Creation, which is I think one of the most famous images of the Hubble Space Telescope. So I wanted to recreate it like ever since ever since I saw the first image of Hubble of it. It's an amazing object, and I never thought I could get something that looks like this when I saw it. I didn't think it even was possible from Earth, but it is. um, so I captured it several times, and in this specific time, I went for, as I said, for the wider kind of view of it, because I wanted to capture the entire Eagle Nebula with the pillars at the center. So the imaging itself, the data gathering was 3 different nights that I went to the desert. 2 was one after the other, and then the next one I took for the final filter, for the sulfur filter. So it's 2 nights that I captured hydrogen and oxygen, and then another night that I captured the sulfur. And the processing, this is like the tricky part, because it's like I would say every artist would know this, that you never know when your image is finalized, like when you're going to say, okay, I'm not going to touch it, it's finalized. But every time I do say this, I I do another another session, and so I would say it took me about a week just to process this data. And I have to say that even just moments before I uploaded the NFT, I did another small session of tiny tweaks and changes to the contrast of the image, because um, it's very tricky sometimes. Those nebulas, like this specific one, it's very bright at the center, but it's very dim at the sides. But you won't still be able, like from just looking at it, to be able to see the details in the center and also the details in the side. If I would just post the image as it was originally, you would probably see like the entire center completely white. You wouldn't see the details of the nebula inside. So
Yeah,
yeah. So as I said, just moments before I uploaded it, I did a couple of more tweaks to the contrast and try to balance it out without, of course, ruining the image, without making it look like it's 2-dimensional. Yeah, so
no,
that's
no,
about my
no,
interpretation.
no, it's true, because we can, when we see like close, we really can see the stars even inside this kind of bright center. And it's true what you just said. It's normally there is always something with less contrast, with more light, for example, and like normally the stars on the corner we can see them more, and the center, because it's bright, normally we should not see that much, the stars. And you manage to make everything details, which is even more, like it gives this kind of impression of it's a painting, it's not a photography, because it's so perfectly, detailed. And yeah, I understand what you mean. Like, if there is not yourself to say, now I stop, it's done, you could do it and review it over and over and over, but
Yeah.
it's you're an artist, so it's normal.
I always see the imperfections, always.
Normal. It's normal. No, it's really nice. So this was when did you took this shot, for example?
I think this was a year and a half ago, something like
Okay.
this.
And so was it on a way? Was it like on purpose for NFT, or it was before you start?
No, it was a lot long before I started NFTs.
Okay. When did you start exactly?
I started
NFT.
about 2 months ago.
Okay, nice. But you
Yeah,
are into the crypto and blockchain sphere since longer, right?
yeah. Of course, I was longer on blockchain. I bought Bitcoin at 2016 or 17, about that.
Yeah, yeah, early stage.
Yeah,
No, but
but I really got into yeah, trying to sell my stuff as NFTs about two and a half months ago, so something like that.
okay.
I of course waited to get an invitation for foundation, and then when I posted several items there.
No, it's amazing. And so far, how many pieces do you have on foundation? Let's go have a look.
I think I have 9, if I remember correctly, or no, maybe even more.
You have more.
Yeah, I have it's 9, 11, 12 images. I have I have 12 images. 4 of them are sold.
Okay.
Uh, one, of course, to to you.
Ooh, to the best DAO, of course. Yes, continue.
Um, yeah. So as I said, I started not too long ago, and I'm very patient in this. I don't want to. I think that my photographs, a lot of them were circling the internet a long time. Like, for example, this Andromeda image and the sunspot image. They
The sunspot, please, can we have insights? It's unbelievable. It looks like a fluffy ball of something beautiful. I mean, it seems really warm, if I can say, but
Yeah. So about the color, the sun is actually white. So this
yeah,
would essentially look, and of course, and this specific image was taken with an hydrogen alpha filter, which means it's on the very dark red side of the spectrum. So if I would show
okay.
you like the original data, it would look completely red. You wouldn't even see almost anything. So of course you have to do some processing, and sometimes people like to color the sun with this orange kind of color, because we humans are used to seeing fire as something yellow and orange and hot. So it causes us to really relate to the way the sun is emitting heat.
Totally.
But it's not, of course, the original color. It's the sun is completely white. It's a little more green than white, but it's mostly white.
Okay, yeah. No, but of course, it makes more sense for the general public to see a sun with this kind of orange, as you say, because it's
Yeah.
assimilated to this color.
Yeah.
So we feel even more what you wanted to transmit, you know. I think if it was just white or green, it would be something like so unusual. Like if you want to link it to the sun, that we will not feel the same as what we see now, or what, for example, it make me feel, you know, this big bull of orange and fire and sun. Yeah,
Yeah.
the fact that you put it in orange makes totally sense. But I saw
For me
one,
too. I mean, I also like it.
this. So this is the normal color. The so
Yeah, so this is like a more kind of monochrome color.
okay,
I like to kind of experiment. So I actually took my video, which is completely black and white, because as
okay,
I said, it's red, and as I said, because it's just a specific narrow wavelength. So
okay.
you can say that it's black and white. Um,
Can I make it?
so as I said, I like to experiment. So I experiment with all kinds of color gradients and palettes, and eventually I stumble into this color, which looked very, very cool to me. So I decided to leave it like this. Um, so this is a huge prominence, about I would say about 5 to 8 times the size of our entire planet. Uh, it was very I was very lucky to be able to capture such prominence, and I like to do those time-lapse video where I aim my telescope for hours and hours to
Mm.
something, for example, this prominence here. It takes a lot of work. It
Yeah,
took
so
me
this was, yes, sorry, yes. So this was, for example, because you said hours of hours. So, for example, this kind of work is like much longer than the other one. Is
Yeah,
that
so the thing is that this is also a lot of data gathered, because to be able to capture the sun and planets, you have to take, instead of one long exposure, you take a lot of short exposures. So it's a lot of frames. This was, I think, about almost half a terabyte of data, just this small video, which was later, of course, condensed into one video. But the initial data was about half a terabyte of data. A lot of small images, hundreds of thousands of small images condensed to each of them. Like each video of 1,000 frames was condensed into just one frame, and those were the frames of the final video.
Okay. Wow. We cannot imagine all the process that there is behind. Like honestly, when we see your art, your photography, we can see that there is something that we simple person cannot do without a lot of connaissance and material, of course, but to imagine all the process that there is behind and all the parameters that you have to deal with and to take care of, it's incredible. It's incredible. And it's just outstanding. You know, for a lot of people, space and actually astronomy, I mean, not astronomy, but the fact to see all of these stars or all of these planets, it's something that make people feel anxious and at the same time really curious, you know, because it's the fear of the unknown. For you, it's something that is.
I get that a lot. That comment a lot of when I post videos of the sun. A lot of people say, "Wow, this is scary," and I would say, "I mean, why? Why is this scary?"
Yeah, what?
But yeah,
It's not scary for you?
no, it's not scary at all for me. I mean, maybe I'm used to it, but my entire life I've known that, you know, we are insignificant and so small. So a lot of things are scary. A lot of things can kill us. That's what I would say. we go in space for 2 seconds and we might, you know, die. We are here safe on Earth, but we never left Earth. So about 99.999% of the universe is dangerous to us and is deadly to us. But you know, just the thing that does amaze me is the sizes of those things. Like to see that the way, for example, this video of the sun, where you see this prominence dancing around, like it's like it looks like flames to us, like something that we are used to here on Earth, but we can't even grasp the size of this. It's those small filaments that are following, as they are the size of entire continents and planets. So it still amazes me that material is able to behave like it is here on the scale that we know, but still be at the scale of entire planets and continents. And yeah,
it's so far away from everything we see on our daily lives that what you just said, it's just to, you know, process it in our mind. It's a real work. So no, it's, and one question, if you can, would you like to go to space to take picture from there?
of course.
Yeah.
I actually answered this question. Someone asked me yesterday about, you know, going to Mars. So
Yeah.
I thought, you know, even if I had to go there and know that I'm never coming back and I'll be alone, completely alone, the rest of my life there, I would go in a heartbeat, like to be the first to land and stand on a different planet. That's like the most incredible thing that someone can ask for.
Okay, well, we wish you, but we wish you that you can come back, please, because we don't have so many photographers who are that implicated in the research of how can I explain, of it's so, I'm sorry, I'm captivating. I have to remove because it's like it's really captivating. No, it's amazing to have photographers who are so passionate, and since you are a kid, actually, for stars, astronomy, and to share it with us, it's really, really nice. So thank you for that. And can I ask you if you have some upcoming projects?
Well, yeah, I have a lot of new things that I'm going for. Mostly, I want to capture in even higher resolution videos of the sun. Like I want to get really close to a sunspot. I have actually did a video a while ago with this new telescope that I modded. Like it's a telescope that isn't designed for the sun. And actually,
Okay.
even when I asked like the company that manufactures the filter that I use, if it's okay to use it with it, they said no, it's not okay. Don't use it, and you won't be able to capture anything. And the worst case, you will burn your telescope. So naturally, I disregard everything they said and went for it. And I've built this specific, this very special cooling system for this telescope to be able to use it still to capture the sun, because I wanted to use it because it's a large telescope, and so it enables a higher zoom and higher details of the sun. So it's going pretty well. I was able to capture some amazing videos. It's a lot more susceptible to atmospheric disturbances, so I need to like very carefully, plan ahead and choose the right date and conditions. I mean, first of all, as we said before, it depends on the atmosphere, but also if you want to capture a sunspot, then you need a sunspot to be on the sun.
Yeah.
Sun, of course, itself is rotating once every 24 days or 28 days. So even if there are sunspots, sometimes they're on the other side of the sun and we can't see them. So you really have to plan ahead. And I want to get an even bigger scope, because after I developed this cooling system, I saw that it is possible to use it and to even get it to work with a bigger telescope. So this is what I'm going to
Yes.
do in the next few months.
Okay, because what is bigger than what? Yeah, maybe I can share. There is a video on your website where you have the kind
Oh
of
yeah.
process. Maybe I can show it because it's important to just realize how already big is your camera. It's more, yeah, it's not really a camera, but I mean, it's a camera. It's a really big camera.
It's it's a camera and on a telescope. So yeah, you can call
Exactly.
it a camera because the lens is the telescope.
Wow. So this is a setup. The
Yeah,
behind the scene.
concept.
Wow.
I have several telescopes. As I said, this one was the one that I use for most of my deep space images.
Okay.
Most of my nebulas and galaxies, and the Andromeda image was captured with this one.
It's amazing. Okay, so now you want to invest in one even bigger to capture even
Yeah.
more details and even more large
Hmm.
view. Of course, it makes totally sense, but I think like you can never stop after, because you even want to see more and more and more, because there is so much to see, because we don't know nothing. So just the beginning for you.
Yeah, and of course it's a very expensive equipment,
Yeah,
so you have to. There are telescopes that cost $500,000, and they're
yeah,
not that bigger than mine, so it's
I
kind
was
of
about to
grows
ask you.
exponentially.
Yeah, I wonder that this kind of equipment costs a lot of money, but when you see the results, and
Yeah,
so actually, yeah, you are followed by already big magazine, no? No, you have sports, no? You are like already known as
I-
a good photographer in
yeah.
astronomy
I'm not, but I'm not sponsored or anything.
for now.
For now, yeah.
It's amazing. Okay, well, it was really nice to have some insights about this wonderful photos. Like it's honestly, it's blow-minded, and I'm sure that the Jenny DAO community gonna be really happy to know more about your process of creation, and cannot wait to see your next project. Actually,
Thank you very much. I appreciate that. Thank you.
David, thank you so much for your time.
Thank you
Bye.
too. Bye bye.